Hey guys, welcome to day 16, take 2. I'm sorry there was a little bit of problem with the sound on the video, so let's see if we can't get this right. All right, so the concept of the mole. It can be a complicated concept, but ideally it was kind of invented to make chemistry a little bit more manageable. So when you go to the bakery, a lot of times you will order donuts by the dozen, and the dozen kind of being a way of counting things in larger units. So a mole is similar to a dozen in that it is kind of a standard way of measuring amount of atoms or molecules in chemistry. Now, realistically, atoms are too small to be counted, and there's too many of them. So we don't actually count atoms, we don't actually count molecules, but rather what we can do is we can measure the mass of a sample, or we can measure the volume of a sample, and from that information we can do some calculations, and we can actually find the number of atoms or molecules. So a mole is a way of quantifying an amount, and objects can be measured in different ways. So the mole is kind of a standard way of measuring how much of a substance is present, and it's a super important topic for the next 2 chapters. All right, now a mole is a measurement, but a mole is also a unit, and we can abbreviate mole, MOL. And a mole is really based on the number of atoms in 12 grams of pure carbon-12. And we know that carbon-12 is an isotope of carbon having 6 protons and 6 neutrons. So 1 mole of carbon is exactly 12 grams of carbon-12. Now, we zoom in here a little bit and we see this number. A mole is actually a number of particles, 602 billion trillion, and this is sometimes called Avogadro's number. So, whereas a dozen is equal to 12 particles, a mole is equal to Avogadro's number of particles. And you will need to kind of commit this number to memory. You'll be using it in a lot of your calculations. I think it should come pretty easy. Now, keep in mind, we can use this to recognize atoms. We can use it to recognize molecules or ionic formula units. We don't actually count atoms, but rather we're going to measure them in other ways and then convert into atoms, okay? All right, because of their small size, this just makes sense. So what we're going to be working on today is making conversions back and forth between moles and particles, particles and moles. And for the most part, these will be one-step calculations. So let's go ahead and do one together. So how many molecules are in 3.5 moles of sucrose? So your 3.5 moles of sucrose, this is your given. Now check out your unit. Here's your unit of the mole. So what we want to do is we want to cancel out moles. And the way that we do that is by putting it opposite, which in this case is on the bottom. So moles is going to cancel out moles. And then what we're going to do is we're going to multiply by molecules. Now, mental note, the 1 typically goes with the mole, and Avogadro number goes with particles. In this case, it is molecules. So with dimensional analysis, remember, you're multiplying by the factor on the top, so 3.5 times Avogadro's number, and then you're going to divide by the factor on bottom, which in this case is 1. So when you do that, moles cancel out. We're going to remain with molecules, and in the end, we end up with 2.1 times 10 to the 24 sucrose molecules. Quick note on sig figs. This 3.5 is going to limit us to 2 sig figs, so rather than calling this 2.11, we should maybe just call it 2.1 times 10 to the 24 sucrose molecules, okay? All right, so let's do another problem. In this case, we want to go from molecules to moles, so molecules being a particle. So if we want to cancel out molecules, we need to put molecules on the bottom. If we want to end up in moles, we need to put moles on the top. So in this case, we are going to show unit cancellation with usually a diagonal arrow. So molecules on top are going to cancel out molecules on bottom. But now when we get our calculators out, we're going to multiply by the factors on top. So 2.11 times 10 to the 24 times 1. And then we're going to divide by the factor on bottom, which in this case is Avogadro's number. Quick note on sig figs. We have 3 sig figs on top. We have 3 sig figs on the bottom. And the 1 mole does not limit our sig figs. So I would say that our answer should probably keep 3 sig figs. And in this case, 3.50. We don't even need to use scientific notation for this one. It's just 3.5 and 3 sig figs. So those are the examples, and I'm going to do a few examples from your homework today, and hopefully you'll be able to do the Google form. All right, so let's go down to 2A, okay? I want to make the conversion from, in this case, atoms to moles, okay? So if I want to cancel out atoms, I am going to put atoms on the bottom. And if I want to convert into moles, I am going to put moles on top. Now remember, you have to kind of keep in mind, where does the 1 go? In this case, the 1 goes with the mole. And the Avogadro's number goes with the atoms. So the 6.02 times 10 to the 23 goes on the bottom. Now let's show unit cancellation real quick. I'll do that in a different color. So atoms, cancel out atoms. Now this is the part where we get our calculator out. So we're going to do 2.5 times 10 to the 22. That's copper atoms. We're going to multiply that by 1. And then we're going to divide by Avogadro's number, 6.02 times 10 to the 23. Quick word about sig figs. We've got 2 sig figs on the top. We've got 3 sig figs on the bottom. So we should probably keep 2 sig figs on our final answer. And when I do that, I do believe my calculator gives me 0.041528. So I'm just going to call it 0.52. Because that 1 is followed by a 5, I can round it up. So if you look down here, you can actually see I did it at my calculator earlier. So number of atoms in this case times 1 divided by Avogadro's number. Let's do another one. All right, so in this case, we want to convert atoms to moles, just like the previous problem. I'm going to put atoms on the bottom because that's what I want to cancel, and I'm going to put moles on the top. So atoms, canceling out atoms. Now I have to plug in my numbers. Remember, the 1 typically is going to go with the mole. Okay, so we're going to multiply by 1, and Avogadro's number is going to go with the number of particles, in this case, atoms. So in your calculator, you're going to take 3.92 times 10 to the 24 times 1, and then you're going to divide by Avogadro's number, 6.02 times 10 to the 23. And if you do that, your calculator should give you 6.51162. We have 3 sig figs on the top, we have 3 sig figs on the bottom, so I think that we can keep 3 sig figs. I'm going to call it 6.51 moles. All right, so the first 2 calculations were from particles to moles. The last 2 calculations are going to be from moles to particles. All right, so for letter C, this time we want to cancel out moles. So moles go on the bottom. And we want to convert to atoms, so atoms go on the top. So moles are canceling out moles. And remember, the 1 typically goes with the mole. And in this case, Avogadro's number goes with the particles. Okay, so in your calculators, 6.572 times Avogadro, 6.02 times 10 to the 23. And then you're going to divide by 1. So when you do that, you're probably going to get a really big number. And I have 4 sig figs in my given. I have 4 sig figs in my given. I have 3 sig figs for my conversion factor, so I can keep 3 in my final answer. And my calculator gave me 3.956, but I'm going to call it 3.96 times 10, and I believe the exponent is 24. So 3.96 times 10 to the 24 atoms in this case. All right, last example problem, guys. We have 8.3 moles of water, and we want to convert moles of water to molecules. So let's cancel out moles by putting it on the bottom, and let's convert to molecules by putting molecules on top. Don't abbreviate molecules. You might get confused with moles. So the 1 goes with the mole. Typically, Avogadro's number is going to go with the number of particles. So in your calculators, you're going to do 8.56 times 6.02 times 10 to the 23, and then you're going to divide by 1. And when you do this, you're going to get a big number, and I can probably keep 3 sig figs, so I'm going to call it 5.15 times 10 to the 24. All right, guys, hopefully this video does have sound. Hopefully everything works as it should. I miss you guys. I love you guys. I'll talk to you soon.